Hello everyone, welcome back. In this video, we're going to do a quiz on glycolysis. I hope you learned a bunch about it in the last few lessons, and now we're going to put that knowledge to a test. We're going to do 10 questions, and I recommend you do them yourself first before seeing the answer. So pause the video or try to answer it fast before I say the answer, and I'll also go over them. I'll explain the answers, and it's going to be a fun, quick video. And hopefully in the next video, we're going to look at some more questions, multiple choice questions that are more complicated and that require more critical thinking. So let's get into it. Question 1. What is the overall net ATP yield per molecule of glucose during glycolysis? So we know in the prep phase, we use 2 ATP molecules. In the payoff phase, we produce 4. So 4 minus 2, right? Overall, we actually make 2 ATP molecules per glucose during glycolysis, so the answer is 1. Question 2. Which of the following molecules is an allosteric activator of PFK1? It's an activator. So for sure it's not NADH. That has nothing to do with glycolysis. In terms of regulation, it's not citrate because citrate inhibits PFK1. Remember, it's an intermediate from the Krebs cycle, and it basically inhibits allosterically because it's a sign of high amount of molecules downstream. So it means Krebs is active and you don't want to produce any more pyruvate because you have too much. And ATP is in a similar way works the same way, because if you have a lot of energy, you want to inhibit PFK1. So therefore the answer should be ADP or AMP if it was here, but in this case it's 2 ADP. Question 3. Which enzyme is responsible for the conversion of glucose 6-phosphate to fructose 6-phosphate in glycolysis? This is easy. It's an isomerase, right? It was step 2, and it's an isomerase, and in this case, a phosphoglucose isomerase. It's not hexo or glucokinase because it's not a kinase, right? Or it's not phospho, so it's not any kinase because you're not adding any phosphate groups. It makes sense, yeah. That's 4. Question 4. The enzyme phosphofructokinase 2 is responsible for the synthesis of which important regulatory molecule? We've talked about this in the regulation chapter. Phosphofructokinase 2, it basically adds a phosphate group to fructose 6-phosphate, and you get fructose 2,6-bisphosphate, and this regulates PFK1. So it's not NADH or ATP. That wouldn't make sense. This is a kinase we're talking about. It's not phosphoenolpyruvate as well. That's way downstream. It's in the 9th reaction. So it's fructose 2,6-bisphosphate. The answer is 2. Question 5. During glycolysis, glucose is converted to which molecule? This is very easy. We start off with glucose, and after 10 steps, remember, from one glucose, you get 2 pyruvate molecules. Therefore, during glycolysis, you convert glucose to pyruvate. And it's not lactate because lactate has to do with anaerobic respiration. Citrate is an intermediate of the Krebs cycle. And acetyl-CoA is converted from pyruvate. So you convert pyruvate into acetyl-CoA in the mitochondria, which can be used in the Krebs cycle. So it's not that either because it's not considered part of glycolysis. So the answer is 1, pyruvate. Question 6. Which step in glycolysis involves the production of ATP? So it's not 1 because glucose to glucose 6-phosphate, we use ADP. It's not 2 because fructose 6-phosphate to fructose 1,6-bisphosphate. We also use ATP. Remember, these are the 2 reactions in the prep phase where you use ATP. Conversion from 2-phosphoglycerate to phosphoenolpyruvate, you don't produce any ATP. However, conversion of 1,3-bisphosphoglycerate to 3-phosphoglycerate does produce an ATP, because remember, 1,3-bisphosphoglycerate has a higher phosphoryl transfer potential, so it can actually transfer its phosphate to an ADP, and you get ATP. Therefore, the answer is 3. Question 7. How many carbon atoms are present in each molecule of pyruvate? This is very easy, and the answer is 3, because remember, we do not have any decarboxylation. So starting off with glucose, which is a 6-carbon molecule, you cleave it into 2 glyceraldehyde 3-phosphates, right? There are 3 carbon molecules, and you eventually get pyruvate. without losing any carbon. So it has to be 2, which is 3 carbon atoms. Question 8. In the muscle, which molecule inhibits hexokinase allosterically in glycolysis? So ATP and ADP do not have an effect on hexokinase or glucokinase, which is in the liver, because that is not the major committed step to glycolysis. It's not 4 because the answer is glucose 6-phosphate, because we're talking about in the muscle. In the muscle, the product of the reaction, which glucose 6-phosphate, actually has a negative feedback mechanism where it inhibits the enzyme, which is hexokinase. If this was in the liver, it would be none of the above, because there's no such inhibition in the liver. So the answer is 3. Question 9. Which molecule serves as the electron acceptor in the conversion of glyceraldehyde 3-phosphate to 1,3-bisphosphoglycerate? This is easy. We produce NADH in glycolysis, and we use NAD plus as the acceptor. It can't be FAD. It's not NADP plus, because if it accepts, you get NADPH, and we don't get that in glycolysis. Therefore, the only answer that is valid is NAD plus. So the answer is 1. Lastly, question 10. Which of the following activates the glycolysis pathway? So a high ratio of ATP to AMP means you have a lot of ATP, and low AMP, which wouldn't make sense. It shouldn't activate the pathway because ATP inhibits PFK1, so it wouldn't make sense. It's not 1. Low ratio of ATP to AMP, that would make sense because low amounts of ATP would not inhibit PFK1, and AMP, high amounts would activate it, so you would have glycolysis active. An ATP AMP ratio of 1, it does not make sense. And lastly, the last answer, glucagon, does not make sense because glucagon activates gluconeogenesis. It's released in the blood when you have low amounts of sugar in the blood and you want to produce sugar, right? You don't want to activate glycolysis because you do not have enough glucose. On the contrary, insulin is the one that activates it, so it cannot be number 4. So therefore the answer is 2. And we are done for the video. We did 10 multiple choice questions. I hope you did well. I hope you learned something. And next time we'll do 10 more multiple choice questions. Bye bye.